How well do you know your chemistry for the MCAT?
Which molecule will have the highest boiling point? So the main thing that influences our boiling point is our intermolecular forces. The three main intermolecular forces we have are London dispersion forces or van der Waals forces. Then we have dipole-dipole, and finally H bond or hydrogen bond. For something to be an H bond, it has to be a hydrogen bonded to any of these three elements: nitrogen, oxygen, or fluorine. If we had it bonded to like a carbon, that would not be considered an H bond. In fact, anything hydrocarbon is nonpolar or LDF. This is going in order from increasing strength. So London dispersion forces is our weakest and H bond is our strongest. Take a look at the molecules. Oh shit, there's a B over here. All right, let's take a look at the molecules. CH4 is methane. Once again, this is a hydrocarbon chain, so it's nonpolar and it only has London dispersion forces. Next, we have CH3OH. This CH3 part is nonpolar, but we have OH right here. As mentioned before, oxygen bonded to H is considered an H bond, so our strongest intermolecular force is our H bond. Now we have dichloromethane. The structure of this looks something like this. We have H bonded to two H's and two Cl's. So C bonded to Cl, the electronegativity difference is high enough to where this is considered a dipole moment. So this has a dipole-dipole IMF. Now finally, we have CH3NH2 or methylamine. Now look at this. NH2 also fits the criteria for H bond. So we know for a fact that A and C are not going to be our answers. Now between B and D, which one do we choose? Because they're both H bonds. Well, some people say that we choose D because there's two hydrogens bonded to N. So there's two types of H bonds and B only has one. However, the correct answer is B. So the reason that it's going to be OH is because although we have two hydrogens bonded to N, the electronegativity difference of O and H is higher than N and H. So this surpasses the fact that there's two types of bonds. So B is going to be our answer.